So in the lesson on vector cross products, we learned about determinants, and in this lesson and in the subsequent lessons, let's look at them and let's explore in detail about determinants. So to begin with, second order determinant. So let me write it down. A second order determinant is defined like so. So A, B, C, D, where A, B, C, D can be any scalar, and we, instead of actually enclosing these four numbers now in a square bracket like we do so for matrices, we enclose them by bars. All right, and this means, and this is evaluated like so. So what we do is that you multiply A into D and then subtract B into C. All right. So let's say, to take an example, let's say if you had to evaluate this determinant 1, 2, 3, 4, its value will be 1 into 4 minus 2 into 3, and this will be minus 2. All right. And now let's look at how we can use determinants to actually calculate the solution for a linear system of equations. So consider this linear system of equations. Let's say a11 x1 plus a12 x2 is equal to b1, and a21 x1 plus a22 x2 is equal to b2. All right. And the solution for this linear system of equations can be determined like so. So it can be written like x1 is equal to d1 by d, and x2 is equal to d2 by d, where d is equal to nothing but the second order determinant, which is composed of all the coefficients for the unknowns. So this will be a11, a12, a21, a22. All right. And d1 will again be a second order determinant, and the elements inside this would be the coefficients of x2. So we'll write here a12, a22, and instead of a11 and a21, we'll replace them by the constant terms here, b1 and b2. So this becomes b1 and b2. All right. And likewise, you can write down what is d2. So d2 will be b1, b2. I'm sorry, that's wrong. So for writing d2, we will leave the coefficients of x1 as it is. So it will be a1, a21, a21, and instead of writing down the coefficients of x2, we will replace them by these constants here. So it becomes b1 and b2. All right. And now if you want to calculate x1, so x1 will be equal to d1 by d, and x2 will be equal to d2 by d. So so I'm not going to prove this result to you because this is a very simple example. So you can actually evaluate d1, d, and d2 on your own and substitute the values and see if it is indeed true. But you can take my word for it, this is true really. So let's look at an example. So let's say if we had the following linear system of equations: x1 plus x2 is equal to 4, and let's say 2x1 plus x2 is equal to 5. All right. So by mere eyeballing this, you can see that the solution is x1 is equal to 1 and x2 is equal to 3. But let's learn the trick that we just learned. Let's use the trick that we just learned a while back. So let's calculate d here first. So what will be d? D will be the coefficients of all the unknowns in that same order. So it will be 1, 2, and then again 1, and then 1. All right. So d will be equal to 1 minus 2, it will be equal to minus 1. Now let's calculate d1. So d1 will be written like so. So you need to remove or eliminate the coefficients of x1 by the constants here. So we'll write 4 5 here, and then leave the coefficients of x2 as it is. So this becomes 1 1, and when you evaluate this will become 4 minus 5 is equal to minus 1. And very similarly you can write down what d2 is also. So d2 will be equal to 4 5 and then 1 1, and this, I'm sorry, I made a mistake again. So d2 will not be this, so d2 will be 1 2, and now you have to replace the coefficients of x2s with the constants here. So this becomes 4 5, all right, and this becomes minus 3. Okay, so x1 can now be written like so. So d1 by d, and this will be minus 1 by minus 1, this becomes 1, and x2 will be equal to d2 by d, and this will be minus 3 by minus 1, which will be 3. So this nifty trick that we have learnt, it has a name, and it's called Kramer's rule. So it's called Kramer's rule. All right. So hope this lesson was illustrative enough, and I'll see you guys in the next lecture.